And I'm kidding.
All right, welcome back, everyone. We're finally in week 3, relational databases, and this is the last week we'll be working with SQL. So, yeah, finally good to finish off that. Okay, so let's go for some announcements first. Announcements: PA2 is due tonight. Hopefully you guys are roughly have worked on it. What are announcements? I think that's it. And for PA1 grading, we're gonna start grading this week and second half of this week, I think. And it should be coming in the next 2 weeks, 1 or 2 weeks for the grading. Yeah, any questions about the logistics or anything? Nope. All right. Let's start with some review.
okay. So this is just a short review of what we've covered so far. We have a client and a server, and whenever the client makes a request to the server, a client is like your phone or your laptop or like a website you're on, and the server is just like a large computer that runs all of the backend code and handles data. So whenever the client makes a request to the route is triggered, and then we do some sort of data operation. So it could be like a simple CRUD operation that could be performed, and then we return this response. Oh, yeah. Before you return, the server sends a SQL command to the database, and the database will return this data back to the server. And then the server returns this response back to the client. So there's basically 3 main places that in the process. You send the request, and then the server receives this request, sends a specific SQL command to the database, and then the database gets this command, gets the data, sends it back to the server, and the server sends this response to the client. Basically the server packages this data in like a format and then sends it to the client. And then within the server is what we've been working on this past week, hopefully in your assignment. You should have like an app.py and a db.py. And then the db.py basically creates this database file. And last class, we created the to-do database. So that's why it's called todo.db. So this is just a high-level overview. Does anyone have any questions before we move on? Okay.
Yep, so hoping that review was refreshing. So this single table, like what we've been working with so far is a single table database. We only have one table in our entire backend, right? And what we have is just rows and columns. The rows with just different objects, and the columns are just different fields, like different features of the object. And you can query and manipulate data with SQL. So now we're gonna introduce relational databases, which is basically like multi-table databases. So this is where we are in the course. We've gone through routes, we've gone through databases. Now we're at number 3. Afterwards, we're gonna have abstractions where we remove and replace SQL with something better. We have containerization and DevOps, how you deploy stuff to the cloud. So you want to like put your backend on like Google Cloud. That's the 5 and 6. Hack challenge will be the hackathon, and we'll also be teaching you guys how to do authentication and images, like how to store images in your backend and how to make it more secure with authentication, like login and signups. All right, so let's keep going with, wait, any questions? Okay. Yeah.
Well, what is like the hack challenge?
Yeah, the hack challenge is so you know how we have like multiple app dev courses like iOS, Android, backend design. So what you'll be doing is we have a group of like one Android, one iOS, or like usually it's just either Android or iOS, like one Android person, like 2 backend people, and maybe a designer. You guys will form a group and compete in like a hackathon, like an app dev course hackathon where you build an app from scratch. So you guys will do the backend, you have the front end people like iOS and Android, they'll make the mobile app, and then you guys will like make a short video. that's part of the grading as well. So that's like the final product for this course, and it's a final product for all the other courses as well. But it's a good way to practice and make an actual thing. And you can build anything you want. You can be as creative as possible. Yep. Yeah. We'll have more logistics for that later, but that's an overview of the course. All right, let's move on. So relational databases. It will allow relationships between data because you have multiple tables now and you can have connections. You can have like which comments belong to which post, which users are friends, and like stuff like that. Let's just get into it. So, this is our first look at two tables instead of just one. We have a user table, for example, this ID and name. We have a post table, post as in like Instagram post, not to be confused with like posting, getting. This is like a like Instagram post. So you can see like one post could be like has a description like deleted either. Yeah, this is not good. But and then you can see how we have the user ID here, and that connects to the user table right here. So you can see which user made this post essentially. That's our first look at like relating two tables. And yeah, you can see here how it relates to that row in the users table. And we do that relationship with foreign keys. So a foreign key is literally just a column in one table that uniquely identifies a specific row in another table. It's also called a secondary key. And in the previous example, the user ID field in the post table refers to the ID belongs to the user now, and then that is the foreign key. So user ID is a foreign key, pointing to a row in the users table. So a foreign key columns is a relationship. Oh, sure. Okay. Yeah.
Okay, so when we're considering relational databases, you want to consider three different relationship types between tables. So the first one is one-to-one, and this is when a row X in table A refers to only one row Y in table B, and this is like for all the rows. So for example, if you have students and net IDs, each student has only one net ID, and each net ID belongs to only one student. So that's why it's called one-to-one. So for example, we have the user table and the net ID table. So Josh's ID is 10 in the user table, and then you can see it's referred to in the net ID table here. Wait, yeah, it's wrong.
I messed up.
Imagine, yeah, wait, the 20 is supposed to be green.
Let me just change it right now. Sorry. Like this would be net ID. This should be mine. 8237. No.
Yeah, so you see like only Josh can only have one net ID and this net ID can only belong to one user. And then this is the same for
Yeah, ignore the
yeah. Yeah, you get the point. And then in SQL, it's defined like this. So a user ID will only be unique. That's a characteristic of a one-to-one relationship. And then you'll have to add a foreign key, which references the user ID is user, which is the table name. So it's up here. And then the ID field, which is like here. So that's how you like create a foreign key and then refer to a different table. And then specifically what field in that table. Yeah, and then if you want to insert a one-to-one relationship, you can insert Josh into the user table, and then to make that relationship, you insert another value into the net ID table, and then you use the user ID 1, which refers to this row that you just added, which is Josh.
switch. I'll do this. So one too many. This one is essentially one object can have multiple relationships with different objects in our table. So the example here is baseball teams and players. Like one baseball team can have like multiple players, but a certain player can only belong to one team. So that's one too many. So like you can have like a baseball team has like many players, but each player can only have one baseball team. If that makes sense. So the constraint here is like the players can only have one team, but not the other way around. And this is how it would look like. So let's say we have an album and a song table. The relationship here is like an album can have many songs, but a song only has one album. I mean, sometimes you can have more than one, but like in this case, the song only has one album. So you can see here, like in the album table, we're using a foreign key once again. Album table, like voice notes, is Charlie Puth's album. He has an ID 10. And you can put the album ID for whichever row in the song table. For like which songs belong in that album, you can put the ID 10. Yeah, that's basically it. It's quite simple. And for like the second one, you can see like these songs are in the second album. Yep. And again, this is how you create it with SQL. This is the reason why we're moving away from SQL in the next lecture, because it looks like it's hard to read. Like obviously you get like even me looking at this is I'm just like lazy to look at this. Essentially what this part does is it creates the table album. This one creates a table song, but it creates a relationship between those two tables with this column. So you have a foreign key, you name it album ID, and then it references an album's ID. So a song will have an album ID to tell which album it's from. And then to insert, it's normal. You insert a new song, you just add the album ID to the end. And if you want to get all the songs from a certain album, this is what you do. You just select from song where the album ID is like 10, and you'll get all the songs in that particular album. Yep. So that's one-to-one. Each one has one-to-one has each row is unique. Like you have to have one. One-to-many is this case where you can have many. And then the next one is want to do it?
Yeah.
It's many-to-many.
The last one is many to many. So this is pretty intuitive from the name. So a row in table A can refer to many rows in table B, and then vice versa. So an example is students and courses. So each student can be in many courses, and each course can have many students. So if you're like wondering what the relationship between two tables is, you can kind of reason it out. Is like you can think about like for a student in the student table, are they allowed to have many courses? If yes, that's like a many relationship. And then you ask the question the other way. Can a course hold or like refer to multiple students? And if that's a yes, then the whole relationship is many to many. And then to implement this, this is like a little harder. So you have three potential choices. The first one is to have multiple columns to store more foreign keys like we've done before, but just like add more columns that hold all the different foreign keys. The second choice is a single column to store a list of all the IDs. Um, this is kind of this is not a really great implementation because it's a list. So if you want to find specific students or IDs in that list, you have to like go through each ID in that list, if that makes sense. And then the third option, which is like the most ideal, is a join or association table.
Right. So we're going to go through each one of those ways, all the three ways to implement a many-to-many relationship. So I have the students table. You have like my net ID, and you can have like courses I'm taking right now. And these are all CS courses. I don't know what I put this in here just to show you like 4620. That's like intro to graphics is this one. And my professor dressed up as like a Dr. Seuss character, and it's it's a really good class. It's my favorite class in my entire time at Cornell so far. If you guys want to talk about courses like to take for CS, like after the class or whenever on Ed, just like post on Ed discussion or just come up. I'll be more than happy like share. And then we have like ML 3780, that's machine learning. This is what you see in machine learning. It's no code, it's mostly just whatever that is. Okay, enough of that. So students table, what happens if you want to what happens if a student wants more than 3 courses? You can see here student table is you only have 3 courses. What if we have a third student that has like 5 courses? Like this person's taking like 25 credits or something, like 2800, 3110, which is an insane course load. Then what you would have to do is you have to have like course 4 and course 5, and then you fill the rest with null, which as you can see, it's starting to look not efficient. Like why do you just have a bunch of nulls here? And this is not good because like if you have a student with 1 course, you have 4 nulls. And in the end, your tables is full of nulls, which is like highly inefficient, right? So the better way to do it, this is method 2, would be to have like a student table and a course table, but now we store the relationship in lists. So like for me, let's say I'm doing these 2 courses, that should be 4620. Then I would be doing, where is it? This and this. So this my course, all the courses in this like list will show what courses I'm taking in the courses table. And then similarly, like you can see in whatever students, all the numbers in this list, you can check up all the students who's taking machine learning, for example. However, if you want to add a new student, you'd have to add that in all the courses they're in. And again, once you add that new student, you have to update, you have to add 3 and 3 here. So you have to insert and then update this as well. So again, this is not the most efficient. You have to like, every time you add a new student, every time someone enrolls, you have to keep updating this course table again and again and again. And another rule of thumb is whenever you have a list inside like a table like this, whenever you have a list, you should generally not good practice in databases. Usually there is a better way to implement it rather than just having lists. Okay. So yeah, let's skip that. The third method and the best way is to use a join table, or is also called an association table. What this does, it does like the list thing, but more cleaner with addition of a third table. So we have a students table, course table, and then we have a third table. You can name it whatever you want, but the term for this is a join table. And what that does is it maps students to course in this table. So you can see all the relationships, all of them are here. So student 1 is taking course this. Student 1 is also taking course 4620. Student 2 is also taking that course. And you can see the relationship here, like student 1, and you can highlight taking those 2 courses, which is these 2 in the course table. And vice versa, you can see if you want to check like 3780, you can search in the join table which ones have that, and you can see which students are taking that. Yeah, so that's a join table. And all you have to do if you want to add a new enrollment is you just add a row there in the join table. So now you can see that Lauren, student number 2, is taking 4620. And we don't have to update lots of stuff. We just have to insert a new row. So insertion is also more efficient with the join table. Right? And the way to do it is, okay, this is the SQL again. I'll just explain it. This stuff is making the student table. This stuff is making the course table. And then we have the join table, which is table in the middle. You have an ID. Of course, every table needs to have an ID. You have a course ID and a student ID. So these are the 2 columns. And then you have these foreign keys. So again, we're using foreign keys to do the relationships. So first you make the 2 columns, and then those 2 columns will reference, well, one will reference students and one will reference courses to connect those 2. Hopefully this makes sense. Does anyone have any questions about this? The SQL is kind of messy, but essentially you're creating a table, you're creating the 2 columns, and then you're connecting those 2 with the foreign keys. That's the gist. Yep. Let's move on. All right, so in this iteration of the course, I'm adding more games and more like stupid things. So we're gonna be having more practice with database design, but in a more fun way. So I'll be splitting the class into 2 again. This is A and this is group B. And you guys will each answer and like try to answer or guess the relationships between 2 tables that I give you. And let's see which team has more points in the end. So I'm 8. So can I get 8 people from each team to volunteer? So like this, I don't know how to count this like properly, but like every time I have like 8 questions, and every time I want different people to answer from each team, right? And the same person can answer twice, just so like more people have a chance to answer. All right, so I'll just go as well. Okay, so number 1, eatery. So we have an eateries table, which is a bunch of like restaurants or like places on campus. And you have an items table, like what food is in the eatery. And what is the relationship between the eatery table and the item table? And the hint here is they both like have pizza. Like if you have an item that's pizza, Oaken and Morrison might have pizza at the same time. They both have pizza. So what is the relationship? Is it 1 too many too many, or 1 to 1? So I need 1 from each. All right, you can go.
I think it's many to
Many too many from team A?
Yeah,
Many too many? Okay. You guys both got it correct. The answer is many too many because eateries and what was it? I forgot. Items. So one dining hall can have many items in the menu, and one menu item can exist in many dining halls. So like you can have French fries in like 5 dining halls. So you have a many to many relationship. Okay, that's number one. So that's 1 point for both teams. I'm just gonna keep score. I guess there's no way to stop you guys from like cheating and just copying each other's answers, but we'll see. It's one each. Okay, ready for number two? Number two, Instagram. We have a users table and a post table like we did just now. And what's the relationship between users and posts? Are you team A? Team A or team B? Okay. Team B, you're team B.
Oh, B, okay.
B is here. A.
Oh.
All right, so you want go? Who's turn is?
One user have like multiple posts, and post only belongs to one user.
Okay. How about team A? The same thing?
Same.
Okay. Yeah, I did not think this through, but all right. Okay. I'll do A after this first. And that is the right answer. It's one too many. So one user can have many posts, but the hint was there like before collaborative posts because like you can have many users for the same post. Um, each post only has one user. So it's one too many. All right. So that's okay, that's two. Now team A goes first. Let's go next. Number three, Spotify. So you have a users table and you have like all the user settings inside a user setting table. So what relationship would that be between users table and users like settings, like their volume, their language, or autoplay settings and everything like that? Team A, what is your answer? You already went, right?
Yeah.
I mean, kinda. You didn't really. Yeah, you can go.
1-to-1.
1-to-1. Okay. And team B, anyone? What's the relationship between users and user settings? Yeah. Okay. What? So you're just both 1-to-1. The answer is 1-to-1. So the reason is because a user has a certain settings, they have one, and then a user settings, like although you could reuse it for multiple users, like a user setting belongs to one user. So you have 1-to-1. And this is an example of when you would use 1-to-1, because I think in the last semester someone asked me like, what's the point of having 1-to-1 if you can just have like bigger tables? Like, what's the point of having like a users table and a net ID table if you can just put a net ID column in the users table, right? And I didn't really have an answer for that last time, but now I do. And the answer is for efficiency, because let's say in this case, you have a user table and you have user settings. Whenever you have like you're going through your app, you open your profile page, but not your settings page, you're only opening your profile page, you're querying the backend. And what if the backend gives you all the information about you and the settings? That's like you don't need the settings data, right? So it's inefficient. So that's why we store it in a settings table. So if you need the settings, then we'll query the settings table based on the user table, based on the relation. Yeah.
So we have many settings, so is that how is that what's one?
So I can draw it real quick. So let's say a users table would be like user, and then you have like ID, you have name, you have like email, blah 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 blah. User settings would be something like in this case, like maybe like the language you have, like the audio quality, maybe audio quality and stuff like that. So every row in this users table, let's say like this. This one would have like different, like a language is here, this is a column, right? And you have audio here. And then this is his users, like this is me, this is Lauren, this is blah blah blah. I would have one like settings, one row to store my settings. But like, I mean, Lauren could have the same settings as me, but like she would probably have her own setting and stuff like that. And there's not really point in reusing this point, because then you just be enumerating and then stuff like that. But like, you get why it's 1-to-1.
Yeah, that makes sense.
Yeah. And we'll have more examples. So was that that's just 3 all, I guess. Okay, next one, number 4. Clash Royale. So hopefully this is not too specific to like a certain demographic, but let's say you have a user table, like a user, like a player, and you have an emotes table. Emotes are just like different like stickers you can use. And these emotes, like I could have this emote and like someone else could have this emote as well. So many players, they might share different emotes. What's the relationship between user and emotes? Many to many. Okay, you're team A, right? Team A. B? 1 too many. Why? Okay, let's hear your thoughts. Like, why many to many?
Because my user can have multiple emotes,
Mm.
right? And the emote and the emote can appear in the user table, multiple users table.
Okay. Do you have a reasoning?
I'm not sure if that's how it works. I thought it was like one user can only have like one emote.
One user can have like multiple emotes. Yeah. Sorry if that. Okay. Okay. The answer is many too many. So, so sorry if that was like a bit too specific, but like a user can have multiple emotes, multiple stickers, and then like a sticker can belong to many users. So you can see how the relationship is many to many in this case. Sorry, I didn't. Maybe this was too specific, but I will give 0.8. All right. Thanks for trying though. Number 4. Tinder. So this one is interesting. So you know how the matching feature works in Tinder? A user can like swipe right, swipe left to another user. So what's the relationship between users and users itself? So let's see who can answer this one. Is it one too many too many, or one to one? Anyone?
I'll go on that 1 second.
I think Team B first. Team B, what's your answer? Like a users can match with how many users, and the users can match with. It's a bit tricky. This was a bit difficult. Does Team B have an answer? Anyone want to try? It's one of those 3. Anyone? Okay, I'll give Team A first. Team A. Oh yeah, you can go.
Many too many.
Many too many. What's your reasoning?
I feel like one person can appear on, well, for one person's user's POV, there can be multiple other users that appear on their like match or don't match like interface.
Yep.
And then they can also appear on many other users like faces.
Yep. That sounds about right. The answer is many to many. So again, this is a recursive relation. This is sort of out of the scope of this class, but I want to like show you users and users. So like a user can like match with different users. Like it can match with user A, B, C, D. But like that user D, he could like, or he or she could match with another bunch of users here. So the relationship is many to many. And this is a cool example. It's like it's just one table and they can have a relationship. It's a bit out of the scope of the course, but I thought it was just cool. So and that's one for A. All right. Number 4, YouTube. So we have a creator table or like a YouTube channel table, and you have a video table, like videos the creator posted. What's the relationship between creators and videos? Team B first. Anyone? Team B. You can answer. Yeah, you can just answer again if you want. One too many. Okay. Yeah. And Team A, I guess. Also one too many. Okay. That's a good answer. This is correct. It's one too many. Because again, yeah, one video can have only one author, and like one author can have many videos. So let's give it close. 1 and 2. Number 5, Discord. You have a users table, like different Discord users, and you have a profile table, like the user's profile. You have like their bio, you have their roles, you have their like when they joined, blah 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 blah. What's the relationship between users and their profile? Let's go with Team A first this time. Team A. Anyone want to have an answer? Yeah.
Is it one to one?
1 to 1.
They have one profile.
All right. And Team B? I should have thought of a better way to do this. Okay, I'm just gonna lock. Is it Team B want to answer? You can
1 to 1.
1 to 1. Okay, that's good. So yes, this is 1 to 1 because one user can have like one profile, one bio and everything, and that bio belongs to one user. So it's 1 to 1. Another example of 1 to 1 is, I mean, 1 to 1s are quite rare, but another example, because you don't want to store everything in one big table. Every time you query that table is going to be a huge amount of data sent to you. So you want to sort of abstract it out. Okay, number 6, Reddit. So you have a post table, like Reddit post, and you have comments table. You're actually going to build this. And what is the relationship between posts and comments? I think you guys already did this, right? So you should be able to do this. So Team B first. What's the answer to this? I think this is an assignment. You can answer again if you want to. Yeah.
I think it's 1 to many. Yeah.
Okay, yeah. And team A, one too many as well. Okay. It is one too many. I'm gonna give it because one post can have many comments, but one comment can only have like one parent post. So it's one too many. Hopefully this is like educational for everyone. Number 7, GitHub. This is the second last one. We have repositories, which is like repos or like projects basically. And each project has like different contributors or people working on it, different users basically. So there's projects and users. What's the relationship between repositories and contributor? Yeah. Many too many. Okay, and team B. There's team B. Yeah. Many too many. Do you have an answer? Like why is it many too many?
Because multiple contributors can be on one repository and one contributor can be on multiple.
Yeah, perfect. So it is many too many because like what he said. One repo can have many people working on it, and a user on GitHub can contribute to many repos. Hey, looks like you guys are getting all of them so far. Last one, Amazon. So Amazon has an order table, different orders that you have. Like I bought like shoes or something, and an order status table. Order status will be like, I don't have it here, or I don't have it here, but order status would be like what date it's gonna come, how much it was, which user bought it, yeah, stuff like that. Those two tables. What's the relationship? And I should have just done who can get the answer faster. But team B, any answer? Relationship between orders and order status. No, team A.
Wait, would the order status table have only like one order information or like all of your orders?
Good question. So the order table is just like, let's say it's just like ID, and then like the ID of the order. You can have like the user's ID. You can have like bunch of other information like what you bought. And order status is just like when it's coming, how much it costs, blah 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 blah. Does that clarify?
Yes.
You have a question?
Is it 1-to-1?
Oh, you were answering to. Oh, my
I'm
bad.
sorry.
Yeah. What's your answer?
Well, if it's only showing like one order, then 1-to-1.
Okay, perfect. All right. I guess team B. No. All right. I'm sorry. But yeah, the answer is 1-to-1. So congratulations to team A. The answer is 1-to-1 because like order and order status, we try and separate those. Usually, easy way to think about it is if they can be combined, then they might be 1-to-1. Because like an order can have only one order status, and that order status belongs to one order. So hopefully that made sense. I spent quite some time making these slides to practice. But yeah, does anyone have questions on the 3 relationships? 1-to-1, one-to-many, and many-to-many. Any questions at all? Great. That means it was very ultra clear. Oh wait, I have one more. Okay. Okay. App Store. Apps table. So you have a list of like a table of different apps, and then a table of different users. What's the relationship between like users can have apps, right? And apps can have which users downloaded it. What's the relationship between these two? Last one. Yeah. Many too many. And you have a reasoning for that?
One apps have
Mhm.
one user.
Yep. Perfect. All right. The answer is many too many. So exactly as you said, one app can have many users and your user can have many apps. That's like literally the explanation you give when someone asks. Yeah, hopefully this was clear to everyone. And now let's go to the demo, and we're going to be doing SQL here. So, oh yeah, I was gonna throw prize, but like I don't have enough for everyone. Who answered from team A? Ion 1, 2, 3, 4. Wait, 1.
That's exactly
1, 2, 3, 4, 5, 6. I don't have enough eggs. Okay, you guys come up and you can get some candy after this. Okay, sounds good. Okay, let's do the demo now. So the demo will just be in SQLite. You want to do SQLite? And again, this is just gonna be SQL, but we'll be doing the foreign key relationship and stuff like that in a real database. So let's go do that.
Okay. So if you open up your terminal, the command to go into the SQLite shell is just SQLite 3. And we're just gonna create these relationships that we just talked about in class. So our first relationship is one-to-one. So for this, we'll create two tables, a user table and a profile table. So each user will have a unique profile, and each profile is only for a specific user. So we can start by creating the user table.
Let's try to as you code. Sure.
Okay, so here I'm making a user table right here with two fields, ID and name. ID is the unique identifier and name is just a string that is not empty. So if we look at our available tables, you can see we have user. And then next, we're going to make a profile table. So we're also going to have a unique identifier, which is an ID. And remember, this ID is like completely separate from this ID in the user table. And we're going to add a net ID. And this is the most important part. We're going to add a user ID. So this is how we connect both tables together using the user ID and a foreign key. So the user ID here, we're saying that it's a foreign key. And then we need to reference this. We need to reference the user table that we created up here. And within this user table, we need to reference a specific field that we're connecting. So in this case, it's the ID. So we can input that. And then that should be all. Oh,
Comma.
oh shoot. Okay.
ID. Missed the ID. Should be ID first. Do it again.
Okay.
Yeah. Comma. And you forgot the yeah, comma as well. Yep. Yep. Huh?
Oh.
It will already exist.
Is that it? Have to go.
I think it is. But you didn't semicolon.
Oh, bro. This is so
Yep.
annoying.
You didn't semicolon. Wait, try.
Okay. This is why we will not be using SQL.
Also, the CLI for like different databases usually is easier to work with than SQLite. Like Postgres is you can have like multi-line text. So it's usually easier than this. This is unnecessarily hard.
Okay. Okay, so sorry about that. So we have the profile table and then we created both tables. So now we're going to insert some data. Okay. So insert into user name. Okay, I need someone to give me their name. Who would like to volunteer? Yes. What's your name? Okay. Does someone else want to give me their name as well? Yeah. Ulrich? Okay. So if we look at what we have in our user table, we have Youngjin and Ulrich. And then now we're gonna add a profile for each Youngjin and Ulrich. So to do this, we're gonna insert into profile net ID user ID. What's your net ID? And then remember, we need to add the user ID, and here we can see the user ID for Youngjin is 1. So that's like the second field. And then Ulrich, what's your net ID?
YC.
3437. Okay, and then Ulrich's user ID is number 2. So if we look at the profile, we can see that this is the specific ID, unique identifier for this profile, but we also have the user ID for each row. And then if we try to insert another profile for Ulrich, so if we add in some random like ABC 1, 2, 3, we can see that our unique constraint has failed. So SQLite, like because we added the unique identifier here, it will not allow you to create 2 profiles for the same user.
Yep. Because it's 1-to-1, so you can't have more than one.
Does anyone have any questions so far?
We have 5 minutes left.
Okay, I will speed it up. So now we're going to do one-to-many relationship. Oh, let me quit. It's okay. I'm going to create a post table.
Integer number. And I'll just explain, you can type. So the post table, we have ID, description, user ID. And that user ID will reference the users table. So that's why we're adding a foreign key here. So that will just be like a new table here, post.
Yeah, so now we have the post table, the profile table, and the user table. So notice how we didn't put the unique identifier here because it's a one-to-many relationship. And then we're going to insert into this table. So I'm referring to the user ID, which is 2. So that would be Ulrich posting that. Oh, yeah. And then
Studying for college.
so Youngjin would also post, smiling through it all, can't believe this is my life.
Yeah.
And then we're gonna look at what we have in our post table. So you can see this user ID refers to Ulrich studying for algo, and then this is Youngjin's post. And then yeah.
Okay, the last one is the many-to-many relationship. So we're gonna make a hashtag table for the post. So you don't need to have like caps lock on for this, so this is faster. Hashtag table, and then we're gonna have an ID, integer primary key, auto increment, comma. We're gonna have a name for the tag, tag not null. Let's make that. And so now when we do dot tables, we have the hashtag table right here. I would refrain from copying me right now because it's just gonna be like type racer. Oh my God, there's so many. And now we're gonna make a feed table. So actually, let's just skip this. Shall we just skip this? We don't have enough time.
You can show this on the screen.
Mm.
It's demo.
I will show this on the screen. That's a good idea. Demo for relational. I'm just gonna show this on the screen so it's faster. Yep. So welcome to the world of teaching. This is what you see when you're teaching. So this is the table feed. I'm gonna create a table feed there. You can have a post ID and you can have a hashtag. And this is our join table. So it's referencing post and hashtag. So you have post and hashtag, and this feed table is in between that connects both of them. So this is our join table. And then you can see you can add stuff like Cornell and LeBron into here. Like yeah. And then this is inserting more. This is inserting. Okay, wait. This was inserting into hashtags like hashtag Cornell, hashtag LeBron. This part here in the middle, this is inserting into our join table. You can see that post like 1 has hashtag ID 1. So that means like post 1 will have the tag Cornell. Post 2 will have the tag LeBron. Post 2 will have the tag Cornell as well. And then blah, 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 blah. And then when you select from feed, when you select from your join table, you can see all your IDs here. So this is the left side. This is the ID for the row. And then number 1 is the ID of the post, and the second column, the third column will be the ID for the hashtag. Yeah, and you have other things like inner joins, but we won't really go into that. And yeah, let's just get into Kahoot. Any questions about this? Sorry, it's a bit too fast.